Hello students, myself Momin Abdullah from KMES English Medium High School and Junior College, and this is your lecture number 4 from oscillation chapter. And in this video we are going to study about amplitude, time period and frequency of a particle performing SHM. So let's first study about the amplitude of SHM, which is denoted by capital A. So suppose a particle is performing SHM on this straight line MN, and at this instant of time the particle is situated at point P. So the displacement of a particle at point P can be denoted by with the help of the equation which we have derived in our previous lecture. So if you didn't watch it yet, go and watch that video and come back here to watch this one. So the equation of displacement of a particle performing SHM can be written as x is equal to a sine omega t plus phi. So if we are saying that we want the value of x to be maximum. So if the term sine omega t plus phi has maximum value, that means x is also maximum. So the particle will have its maximum displacement. The value of x will be maximum if the term sine omega t plus 1 will have maximum value, and the maximum value of sine is plus minus 1. So if this term sine omega t plus phi has the value plus minus 1, so x we will get plus minus a. And this distance a is called as amplitude of SHM. So amplitude can be defined as the maximum displacement of a particle performing SHM from its mean position is called as amplitude of SHM. Suppose the particle is situated at mean position, that means point O is the mean position, and the maximum displacement in right direction is n. This On is the amplitude of SHM. Also in left direction its maximum displacement is Om. This distance On and Om is called as amplitude of SHM. That is the maximum distance covered by the particle. Now next, period of SHM. The time taken by the particle performing SHM to complete one oscillation is called as time period. Now suppose the particle has started its motion from the mean position. So when it goes to n, then it will come back again to the main position, and it goes to m, and then again it. So this set of motion is called as one oscillation, and the time taken by this particle to complete one oscillation is called as time period. So we know that the displacement of a particle is x is equal to a sine omega t. This is the same equation. So after time, let's say 2 pi omega, the displacement of a particle will be. So we are going to increase the time by the amount of 2 pi omega. So the time has been increased by 2 pi omega. So we will add 2 pi omega into t. So now equation can be written as x is equal to a sine omega in bracket t plus 2 pi omega and plus phi. So now omega is going to multiply with the bracket. So omega t into omega 2 pi. Omega will get cancelled. Now we will get x is equal to a sine omega t plus 2 pi plus phi. And we know that sine omega t plus 2 phi is equal to sine omega t. So this will be equal to sine omega t, and the equation which we will get, x is equal to a sine omega t plus phi. Now compare the final equation and initial equation, both are same. So if the initial equation and the final equation both are same, so we will say that this result shows that the particle is at the same position after the time 2 pi by omega. Now this means that the particle completes one oscillation in time 2 pi by omega. It can be shown that when time, that is capital T, 2 pi is the minimum time after which it repeats the oscillation. So if the particle is started from this point and it is completed, and when it comes back to this point, the time will be 2 pi omega, and this is one oscillation. So after one oscillation, it is going to repeat the same set of motion again and again, and this time is 2 pi by omega. So we will say that the time period t is equal to 2 pi by omega. Now from the above equation, we can write omega can be written as 2 pi by t. Now time period is 2 pi by omega. So instead of omega, we will write t, and instead of sine, we will write omega. So we will get the equation of omega as omega is equal to 2 pi by t. But we know that omega is nothing but root k by m, where k is the force constant and m is the mass. So squaring this equation, omega square is k by m, and we know that force, restoring force, is minus kx. So from this equation, x will goes another side of this equation. So we will write k is equal to f by x, or f is nothing but mass into acceleration, that is m into a upon x. So k can be written as ma upon x. So putting equation 2 in equation 1, this k can be written as ma upon x. This m and this m will get cancelled, and we will get omega square as a by x, where a is the acceleration and x is the displacement. So omega square is equal to acceleration divided by displacement, and omega can be written as root acceleration divided by displacement. And we will say this term acceleration per unit displacement. So in the formula of t, we have omega in denominator 2 pi by omega, or instead of omega, we are going to put acceleration per unit displacement. So t can be written as 2 pi divided by root of acceleration per unit displacement. So t is equal to 2 pi by omega, that means 2 pi by root k by m, because omega is root k by m. So we are going to put this omega instead of this equation of omega instead of omega. So denominator of the denominator becomes numerator. So t is equal to 2 pi root m by k. Now frequency of SHM. So frequency of SHM is nothing but the number of oscillation performed by a particle performing SHM per unit time. Now frequency is number of oscillations per unit time. In time t, the particle perform one oscillation. When it starts from the mean position, so to complete one oscillation, his had been taken a time of capital T. So we will write frequency is number of oscillation is 1 and the time taken is T. So N is equal to 1 by N T. And we know that T is equal to 2 pi by omega, or T can be written as 2 pi by root K by M, or 2 pi root M by K. So we are going to derive the formula of frequency. So we are going to reciprocal these terms. So 1 upon 2 pi by omega can be written as omega upon 2 pi, or frequency can be written as 1 upon 2 pi root k by m. So this is it, student. I hope you understood the concept, each and every concept very well. Thank you very much. I will catch you next time.